What we're going to be looking at today is a way of describing a line and describing it mathematically. When I say mathematically, don't get scared by that. It just means we're going to represent it with a function. Okay, so every line is technically a function, and we're going to be taking that function and trying to represent it, sorry, not by a function, but by an equation. Okay, we're going to be using an equation which represents the function. This line is a function, and there is some equation which represents that line. Okay, and this one right here would be y is equal to 2 over 3x plus 2. There we go. There's an equation which represents that line right there. Okay, but we don't want to, or we need to figure out how do we come up with that equation. Now again, I've done way too many of these, and so I can do it really quickly, but we're going to go through what is a way that we can come up with that function. The first way that we're going to look at is something called slope-intercept form, also known as graphic form. And I'll explain why we call it graphic form in a little bit, but it's also called graphic form. Now, important things to remember here. Each linear function or straight line, okay, so any straight line that's on a graph, can be described by some, and I'm going to put equation in there. Okay, it says the original is form, so that's why it's a little bit of a smaller one, but it should be equation. It's described by some equation. Okay, if the slope of a line is given, or we can find it, and the y-intercept is known, or we can find it and is a nice number, we can use slope-intercept form, so it can be used to describe the graph. So we can use slope-intercept form or graphic form to describe our graph. Okay. Now, slope-intercept form looks something like this here. Y is equal to mx plus b. Okay, that's what it looks like. That is the form that we have. Okay, and we're going to represent that as a function. Okay, or as an equation. We're going to use that to create an equation. Now, the important thing in any equation is to know that the x and the y are any point on the line. Okay? For the sake of this form, they will always be left as x and y. Okay? So these ones right here, remember, these are, we can also call them variables. Okay? Those are variables. So in any single equation, these are going to represent our variables. Whatever our x value is, it's going to have a specific y value attached to it, but we could use any x value. We could use 0, 1, 2, 3, 4, 5, any single value in our equation, and we're going to come up with a y value which represents that. So those are our variables, the x and the y. We're going to leave those. We're never going to change them when we create an equation. We're only going to change them if we're trying to solve the equation. Okay, so we're only going to change them if we're going to solve the equation, which we will do at some point yet. Then the m that's in there, some of you might remember what m is. M is slope. Okay, so m is the slope of a line. We're going to leave it as a fraction or a whole number if possible. Decimals are not usually used. We can if they're nice decimals. Okay, so a decimal like 0.5, that works. We can use that as a slope. It's also represented as 1/2, 1 over 2, a rise of 1, run of 2. Okay, it's easier to see the rise and the run if we leave it as a fraction than if we change it into a decimal. So that's why we're always going to try to leave it as a fraction, because it's easier to understand the slope, the rise and the run of it. Okay, so this right here is our slope. So what we're going to do is, when we know the slope of our equation, we're going to plug it into here. Then, okay, the b. Okay, b is something that's a little bit new to us here. This is our y-intercept. Okay, so in the coordinate point, so the coordinate point that we have, it's the y value. So it's that last value right there. Okay, so this right here is our y-intercept. Now, I showed you an example that I came up with earlier, and I want to go through it really quickly here. Okay, so just remember this, and we'll go through that. Y equals 2 over 3x plus 2. I took this line right here and I found that the slope was a rise of 2 and a run of 3. So 2 over 3, and so I plugged that in for the m right in front of x. So it's 2 over 3 times x. And then our y-intercept is at 2, okay, 0, 2, and so we plug the 2 right in there. If this is a negative value, that means we have a negative intercept. If it's a positive value, we have a positive intercept. And we're going to be taking a look at some examples as to how to use slope-intercept form to come up with an equation which represents the function.